Hey guys, this is your friend Coderjeet, and in this video I'm going to talk about a topic that has confused a lot of programmers, especially if you're starting out new and you've been programming in some other system. Electron can be a little bit confusing, especially the part about the inter-process communication. So in this video I'm going to talk about that, and I'm going to try and simplify it as much as I can. This video will teach you how to do inter-process communication as it is recommended today, with node integration turned off and context isolation turned on. First, a little bit of a background. Electron is divided in two processes. The Electron software, any standard application that you make in Electron, has a main process and a renderer process. And these two processes have completely different responsibilities. The renderer process is going to be responsible for all the display portions of your application. The interface, how it behaves on the front end, that's all the responsibility of the renderer process. And that is running on Chromium. But it cannot work with your computer in the backend. For that, you need to go to the main process, which is running on Node runtime, and there it can communicate with the computer. It can run node plugins, it can run node scripts, and do all the things that the renderer process cannot. Now the thing is, the new model of Electron says that you should not directly communicate between the main process and the renderer process, because you might end up calling things from the renderer process which might create a problem on the PC. It's all about security, it's all about preventing your app from being hacked. Here's what happened. In earlier times, if you switched node integration on, and I will be talking about that a little more, the renderer process can call any function in the main process directly, and that might cause some kind of script attacks if a hacker wanted to do something with your application. And your application, because it's a Chromium debugger application, it's a Chromium app, it can talk to the internet. They can induce scripts in your application that can run malicious code on your website, on your computer, on the computer of the user, and that's definitely not a good idea. So now the current IPC model says that the renderer process has to be pretty much isolated from the main process, and all the communication with the main process should be exclusively through the preload script. So we have got three important files. Any interface, let's say any window that you make in the app, any screen that you make in the app will have three files. The first will be the renderer file, the renderer JavaScript, which deals with all the interface work. Like if you got buttons there, if you got stuff happening on the screen, all of that will go into the renderer.js or renderer JavaScript file. Of course, you can call it anything you want, and I don't call it renderer.js mostly, but it is going to deal with the renderer exclusively. Then you've got the preload script, which is also actually a part of the renderer process, but it has got more rights. In the sense, it can talk to the main process. So let's not waste any more time and take a look at code. I know that's what you want. So I've set up an application where we're gonna see how to do the inter-process communication. And I like to keep my things really organized. So let me give you a brief about how I organize my app. So I've got the views folder. This is where all the HTML stuff goes in. This is the front end of the app, the HTML code. And in view scripts, I've got all the renderer files, all the renderer.js files, and that includes the preload. Of course, the preload is also a part of the renderer process, and the index.js in this case, which is my renderer.js file, or the renderer file, which is going to be included in index.to HTML. Right now I'm using index.html actually. So I have included the file index.js in here. Let me try to show it to you. Yep, you can see the code over here. It's included right over here. So this file is actually a part of the index.html page. It's called in there. The preload, this is the preload file, and our main process is actually running using the main.js file. So this is the main process here. And let me show you how to do the communication. Let me run this app to quickly show you what we are trying to do here. So back to the terminal now, and I use NodeMon. NodeMon is an application to help you automatically run Electron again. Even it works for Node too. Whenever you change something, the project automatically runs. So it's just loading now. And I've got my beautiful app here. So this is the app. It's just a standard web page. I pulled it from the net somewhere. It's a hotel website actually, but it's enough to for our purpose to check out the demo. So it's got this nice little form here, the contact us, name, email, phone number, and messages. It's asking for some details. Let's make this app save these details to the hard disk whenever somebody fills this in. So to do that, we need to have some code in the renderer.js file, the renderer file which is connected to the main web page. Let's go back to the editor. We need some code in the renderer file which is connected to the main web page. We need some code in the preload file to send that data to the main JS, which is where our IPC main is, and this is where we will be able to modify the file system. We cannot modify the file system in the renderer process. We have to do it in the main process. So let's see how to do that. To save time, I have my scripts ready. I'm going to paste them in and I'm going to explain how it works. So let's start with the file index.js. Let's see what we get in there. So it's just a event handler. We have a button over here called btn send. It's this button. Let's go back here. It's the submit button. So it should probably be called submit. I have already created it for you. Okay, so it's the wrong file. We have to check the index.html. Yep, that happens sometimes. So it's called send button. This is the button. And the code that we just wrote in the renderer, what it does is first pick the button using the document query selector, then add an event listener to it, the click event, where we capture all the data from the form. So we've got a name, we've got a phone, email, and the message. And I'm using standard query selector calls, picking up each control and the value of the HTML element. And here I'm making a call to console.log in the render process, and I want to show you what it does, where it logs this little message. So this is it for the index.js file. We are communicating with the HTML content which is displayed on screen, and that's about all we can do. And I will explain this line to you in a moment. This is actually the line which communicates with the preload, but we need to have code in the preload file first. So I'm going to add the code for preload file now, and let's take a look at that too. So here's what I've done. I have a function called send submit, which is taking an argument called lead, and I'm writing lead to the console. I'm also writing a little message to the console here, and then I'm using the command ipc renderer.send. This is the actual game changer. This is the most important line in this code. What this line does is it sends whatever content you want to send to the main process in this particular event. So what we have here is a got lead event, and in got lead event we are passing the lead here, but the main index file can't just directly read send submit. You can see that I've got here window.bridge.send submit. There's a reason for it, because of context isolation, you have to actually tell preload.js or the preload file exactly what you want to expose to the renderer, to the main renderer, to the JavaScript file that's connected to the HTML, because it cannot just automatically read all the functions that you write in the preload file anymore. And you do that through a bridge. There is a function called expose in main world. in the object context bridge, and you can make context bridge a part of your preload file using Electron. Just do require Electron and bring in context bridge from Electron, and then you can call context bridge dot expose in main world. Give your bridge a name. Actually, you can have multiple bridges, and that's something I do when I have multiple forms in a page. I have multiple bridges, or whenever I want to group some functions by special categories, but you can give it any name you want. I'm calling my this one bridge, very imaginative. And you can expose an object. It's a standard JSON object, standard JavaScript object, where you can have all the functions, or and if you have got any variables, if you got any values, you can pass that to. And the JavaScript file that is connected to your index.html will be able to read those. So right now what we've done here is we've got an object called index bridge, in which we are exposing the send submit function written right over here, and exposed using the expose in main world command. The main renderer JavaScript file will only be able to see the functions that you expose using the expose in main world command. And here you can see I'm referring to it by window.bridge.send submit. So now it can call it from the preload function, from the preload JavaScript file. And in the preload JavaScript file, what we're doing is ipcrenderer.send to send a message to main.js. And now let's write the final piece of the component, the main.js code that will actually handle that message. And what we have here now is ipc main.onGotLead. And in that we've got two options, event, two arguments, event and lead. This is the actual lead. And we are logging out a little message. We are logging out the lead itself. And then we are converting the JavaScript object into string using JSON.stringify, and finally using file system.write file sync to read the file to in hard disk. Let's see it in operation and we'll understand exactly how it works. All right, so let's run it and take a look at exactly what happens. So I'm going to fill in some details over here. Just some fake stuff. Okay, a lot of typos. Okay, click on submit and take a look at what happens in the Chrome Developer Tools. First, view script submit click. Let's take a look at where the code is. In the index.js, we have this view script submit click, and this is a part of the render process, as you can see. Then this particular line where it's printing out the lead, all the text that we put in, this is an index preload. So you can see that this is also a part of the render process. You can see render process send submit. That's also a part of the render process. We are logging the lead over here, and right below it we are logging a little message, render process send submit. So till then all the code is running in the render process. Then right over here we call the function ipcrender.send and send a message to the main process. This is going to be in main.js in this function, and you can see right over here that we have a message main process.gotLead, but it is logging in the terminal that is a part of Node. You can see the main process got lead, this message, it's logged in here. It's not logged in the render process. This is the main process debugger. And right below that we've got the lead. And finally what I'm doing is I'm writing the lead to a file called mylead.json in C drive projects.test folder. So let's take a look at that folder over here. Here is our file mylead.json, and yep, the lead is all here. This is exactly what we put in. So it is working correctly as it is designed to. So a quick recap of what you need to do for inter-process communication in Electron when you've got the context isolation turned on and node integration turned off. Here are those settings. This is the main window. This is the window that I've got all the interface in. I create a new instance of it using the create window function, and here I've got context isolation as true and node integration as false. And now these are the default settings in Electron.js. When you run things, this is how it's gonna be set up as. context isolation is going to be true, and node integration is going to be false to improve the security and make your application safer, to make Electron safer for everyone. So here's again what you need to do. In your main HTML file, you need to link to a renderer JavaScript file. In our case, it's index.js. In index.js, you cannot directly call any node function. For that, you need to refer to the preload file. You can only call the function that the preload exposes in the main world through a bridge. So here I'm doing all the interface work. Then finally, I am taking the information, I'm taking the little data that I've got and passing it to the send submit function, which was exposed to the renderer.js file, renderer JavaScript file. In this case, it's called index.js, using the bridge. And inside of the preload file, what you can do is you can create all the functions you want, you can create all the data points you want to communicate to the main process, and you can expose exactly the information that you want to expose using a bridge. It can be an object, it can even be a single function, it can even be a variable. Whatever you want to expose to the main world, you can, but only those objects that you expose to the main world will be available in index.js. Finally, to communicate with the main process, you have to call the function ipcrenderer.send, and that will call the function in the main world, in the main process. Now, I want to tell you something. ipcrender.send is not the only method to send a message to the main process. There is also ipcrenderer.invoke, which is captured in the main process using ipc main.handle. That's another way of doing things. So there are actually three different methods, but typically ipcrenderer.send can be enough for you to send messages to the IPC main process, where it can be handled and you can do all the background work to communicate with the file system or run node commands in the main.js file. Hope this tutorial was helpful to you. For more tutorials, please subscribe to my channel and watch this space for more exciting stuff to help us all become better programmers. This is Coder Jeet signing off.